In this video, we are going to talk about significant figures. Now, significant figures are used to accurately represent numbers and results from different calculations. So let's start off by asking this question. What is the product of 2 times 3? If you said that the answer is 6, well, good. But I argue and suggest to you that 2 times 3 is actually equal to 5. Yeah, Dr. Olson's been on something tonight. Okay, so where's my proof? Here's my proof, 2 times 3. Now, my question here is, do I know that that's exactly 2 and exactly 3? What if those are just the rounded results of 1.7 times 2.9, which when I multiply gives me 4.93, and when I round all that together, guess what I get? 2 times 3 equals 5. So I suggest to you that 2 times 3 equals 5. Now, very obviously, I'm wrong. 2 times 3 is still equal to 6. But what happened here? This is sound logic. So what happened here? The problem was that when I gave you the question 2 times 3, I did not give you enough information. That's why we need significant figures, to make sure that we accurately represent results based on the amount of information that we are given. So there are two main purposes for significant figures. First, it gives you more accurate data. In other words, it makes sure you have enough decimal points. That's the good example that I had in this slide. Make sure that there is enough information both in the question and in the results. The second purpose of significant figures is to minimize errors in my calculations. Now, everyone's done it. They've pulled out their calculator and done some calculation, and they have a number that fills the entire screen, 10 decimal points or more. Not all of those digits should be used because they indicate to the person you're talking to that you are accurate to that decimal point. But you don't know if you're really accurate to 10 decimal points or just accurate to 1 or 2 decimal points. So we minimize errors by making sure that we don't have too many decimal points. So I'm going to tell you first of all what counts as a significant figure, and then after we go through that, we're going to talk about the rules of using significant figures in calculations. So the first thing that counts as a significant figure is any non-zero digit. The numbers 1 through 9 automatically are significant. If there's a digit there, a non-zero digit, it is an important number. So all we have to worry about now are zeros. If there is a zero in between two significant digits, then that is significant as well. For example, here is 506. The 0 in the middle is important because it tells us there are 0 tens in my number. 5 hundreds, 6 ones, but 0 tens. And that is accurate, so it is a significant digit. Any trailing zeros to the right of a decimal point is also significant. For example, here I have 0.002540. The 2 zeros on the right suggest to me that my measurement is accurate to that decimal point. So that would be my tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millionths place. My measurement is accurate to the 10 millionths place, and so those 2 zeros are significant. So what does not count as a significant figure? Any trailing zeros that are to the left of a decimal point. For example, this number, I have 5,402,600. Are those last 3 digits rounded to 600? Or is it really 572 or 641? I don't know. All I know is that at least those last 3 digits are at least rounded to 600. Therefore, I don't know if those last two zeros are accurate or not. So they are not significant. What would happen if I put a 0.0 at the end? So I'd have 5,402,600.0. Well, that 0.0 is a 0 to the right of the decimal point, so it would be significant. Basically, it says I have measured accurately to the 10th place. So that is a significant digit. So if it's 0.0, if that's significant and the 6 is significant, then the zeros in between automatically would also become significant. Last one, any leading zeros are automatically insignificant. 0.00254, the 0.00, they are not significant. Or 00125.0, the leading two zeros are also insignificant. The zero after the decimal point is significant, but the leading zeros are not significant. Okay, let's talk about the rules of calculation with significant figures. There are two rules. One is for addition and subtraction. The other rule is for multiplication and division. We'll start off with addition and subtraction. To see this rule, we're going to take this example of 34.6 plus 41.73352. The 41.73352 is accurate to the 100,000ths place. So that's pretty good. That's a good number. But the first number, 34.6, is only accurate to the 10th place. So I ask myself, is that 34.6 accurate? Or has it been rounded to 34.6? I don't know. So to solve this, we use the rule for addition and subtraction, which says that we round the answer to the least significant decimal, which in this case would be the tens place. So if I add them up, which gives me the result of 76.33352, I have to round my answer to the 10th place because that is my least significant decimal. And so my answer would be 76.3. Okay, let's do the rule now for multiplication and division. We're going to do this by using 5.37 times 13.21943, which gives us a result of 70.9883391, and then possibly some more digits after that. I can't remember if there are or not. You can plug this into your calculator and find out. So the first number, 5.37, is accurate to the 100ths place, whereas 13.21943 is accurate to the 100,000ths place. So where do I round here? I don't know what to do. Well, the rule for multiplication and division is to round the answer to the least number of significant figures. Here's how that works. In 5.37, we have 3 significant figures. Whereas in 13.21943, we have 7 significant figures. But we want to round the answer to the least number, which means we want to round our answer to 3 significant figures. So I round it to that point. Now, I don't want to ignore all the numbers to the right of my line that I just put up here. They are important. They're not accurate. They're not significant, but they are important. So I need to round my answer using those numbers. Therefore, my answer would be 71.0. So there is a description of why significant figures are important, what counts as a significant figure, and also the rules of significant figures, both for addition and subtraction, and also for multiplication and division.